Okay, good evening. I know we're all a little sad about our Panthers' loss yesterday, but we're going to keep pounding and keep cheering on our Panthers. We have one small loss. It's a small setback. We'll be okay. So tonight's video is on solving systems of equations. You might want to write systems of equations and the date for your homework notes for tonight. And it's when we take two linear lines and we look to see how they look graphically. So basically we graph these two lines. So you can see we have y equals negative 2x plus 5. So here's my y-intercept of 5. Slope is negative 2, down 2 over 1. And then we have y equals x plus 2, y-intercept of 2, up 1 over 1. So you can see these two lines intersect in one place. So this intersection here is called the two lines solution. So here we say the solution of these two systems of equations is 3, 1, and it's called a consistent systems or system, which means it consistently has one equation. So what we're saying is x equals 1 and y equals 3. There's my 1 and my 3. If I plug these two values in for both equations, they will be true. So if I look at this first equation here, which was negative 2x plus 5. So I take my, I'd plug in my 1 here and my 3 here. So here's my 3 is my y, my 1 is my x. We work out the math and I get 3 equals 3. So that works. So I want to take this same solution and plug it into the next equation, which is y equals x plus 1. So I'm going to put the 1 in for the x. Or x plus 2, excuse me, and the 3 in for the y. So 3 equals 1 plus 2, and then 3 equals 3. So I have the checks here because this solution works for both equations, and we've done a little bit of math with that. Okay, so we're going to look at another example here. Here we have two linear equations again. We have 4x plus y equals 24, and we'd have to solve that by subtracting the 4x over. So we'd have a y-intercept of 24 and a slope of negative 4, which is this purple line. And again, we'd have to put this into y-intercept form to get this line. But the point being, these two lines intersect here. So again, we would say the solution is 5 and 4. Okay? And so what that means again is if I put 5 in for x and 4 in for y, it'll equal 24. And if I put 5 in for x and 4 in for y here, it'll equal negative 2. You can see the math works out over here. So this is a consistent systems. Okay, so that's one type of systems of equations. So let's look at another example. You're going to have to do some of these on your own tomorrow. So again, we're going to look and we say the y-intercept here is negative 3. So I'm going to put a point here. My slope is 2. So up 2 over 1, up 2 over 1. I'm going to draw my line through my points. Let's kind of make that a little bit better here. It's hard on these lines because they don't always quite hit it right. Okay, and so then we're going to go over here and we have a y-intercept of negative 1. Start here. And a slope here, that's going to be a 1. So it's going to go up 1 over 1, up 1 over 1. And we're going to draw our line. We'll go Christmassy here. And we'll see our line goes like here. And you can see that it intersects right here. So it's a consistent systems with a solution of 2, 1, because this is 0.21. My x is 2, my y is 1. So if I check my work over here, 2 in for x, y in for 1, that gives me 4 minus 3, or 1 equals 1. And again, plug in my 2 for x and my 1 in for y, and I get 1 equals 1. So those both work, and I know I'm good to go. So let's look at the next. Here was the solution, so they agreed with us. They plugged it all in, got 2, 1 also. So let's look at the next example. Here we have, again, two linear lines, so we're good to go. So we're going to graph that. So we have negative 3 is the y-intercept here. with a slope of 1. So we go up 1 over 1, up 1 over 1. And then we're going to draw our line. So you should be doing this with me. Or you could do it first and then check your answer second, which would be good too. So we'll do this, make that fit a little bit better. Okay. And then we look at our second equation, y-intercept of 2, and a slope of 1. Up 1 over 1, up 1 over 1, and then draw our line again. And you can see here that these are, hopefully you notice, they are parallel lines. You can also tell something's a parallel line by its slope. This has a slope of 1, and this has a slope of 1. So they rise and run at the same rate, so they're never going to cross, okay? So because these are parallel lines in this systems of equations, there is no solution. Okay, so parallel lines have no solution because they don't ever cross in a point that they can share. Therefore, it's called an inconsistent system, okay, because they are parallel lines. And let's look at one other example. Here we have, again, 2 different lines. These are in standard form, so we need to put them into slope-intercept. So we'll subtract our x here, and we'll get, make sure you know that's negative y equals negative x plus 2. It's positive 2, and that's 1. Oops, I need to do that. Negative y, that's a 1. So we want to divide through by negative 1. And so it's going to give me y equals negative over negative is a positive x, and 2 divided by negative 1 is a minus 2, right? So we want to do the same thing down here. We're going to add the 2 over, and then we're going to have 2y equals 2x plus 4, and then we divide through by the 2. Actually, I think this was supposed to be negative 4. I messed up on that. All right, and so that's going to be y equals x minus 2. So hopefully you notice that these are exactly the same line. So we have negative 2 and a slope of 1. Okay, and so because these are the same lines, we call them dependent systems. There's no intersection, they're the same line, right? So these are called a dependent, these are called a dependent systems. And I'm going to ask you tomorrow, how many solutions does it have? You tell me. What would be my answer? We found, so far we have no solutions. We've come up with one solution, which is the point. What do you think the solution answer is for when it's the same line? So we'll start the conversation with that tomorrow. I hope you have a great evening. Hi, Chad.